My name's Jamie Cool. I'm a program manager at Microsoft. I'm part of the Silverlight.net team, and that's a part of the developer division here at Microsoft. And today, along with my colleague Nick Kramer, who'll be joining us shortly, we're going to be talking about the integration of the .NET framework into Silverlight. Now, this is very exciting for me because as a member of the developer division at Microsoft, my job is pretty simple. We build tools and APIs to try and make the lives of other developers easier. And for the last 7+ years, what we've been doing has been building up the .NET framework. And now what we're doing is taking a good chunk of the framework and bringing it to the Silverlight platform and making it accessible for a whole new set of applications, these rich web applications. So as you can imagine, we have a ton of stuff to talk about today. We have more than 2 hours worth of stuff to talk about, so we actually have part 1 and part 2 of this particular talk. But for all intents and purposes, we're going to treat it like one big talk. Nick and I are going to go to the end of this session. We'll stop for intermission. We'll come back. We'll keep right on going. In terms of questions, we'll try to leave time at the end of part 2 for questions. And if you have stuff that you just can't wait, Nick and I will be around during intermission. At the end of part 1, everybody here, if they want, can pick up a .NET Framework Silverlight poster over in the corner here. So that's a pretty good poster. So let's go ahead and get going. In terms of formats, I'm going to give you an overview of the .NET and Silverlight project. But for most of the talk, we're basically going to be building an application using the various pieces of the .NET framework in Silverlight, from UI, building controls, networking, XML, link, HTML integration, and a variety of other features as we go through this. So let's dive in. Now, before we talk about what exactly we're building, it's important to understand the scenario that we're going after. The scenario is very clearly the RIA app. And I think almost everyone here should know what a RIA app is. It's this rich web experience. One of my favorite examples of a RIA application is the Outlook Web Access client. If you're not familiar with Outlook Web Access, it's basically the HTML browser version of Outlook. What we were trying to do was replicate as much of Outlook's functionality in the browser for your rich email browsing. Now, an interesting bit of trivia, I was in the Exchange team when we were building one of the first versions of Outlook, of the Outlook Web Access client. And we needed a way to get access to your email messages, right? We wanted to get your email messages from the server in some kind of XML form, bring them back to the client, and then render them in DHTML. And it turned out at the time there was actually no good way to go about doing that. So we built this object called the XML HTTP object just for the Outlook Web Access client. Eventually, IE ended up shipping that. Eventually, a little bit later, other browsers implemented that, and now that's a core part of the AJAX frameworks. So with the Outlook Web Access client, we were really going for 3 things, right? We needed reach. That was the whole point we were building it in a web browser. We needed rich UI experiences. We were trying to do as rich a UI, as close to Outlook in the browser as we could. And as much time and as much energy as we put in trying to do that, and as good as the application is, frankly, if you had to use it for your everyday email browsing, it would come up short, right? It would be very painful to use if you ever used HTML email clients like I'm sure we all have compared to real clients. Now, with Silverlight, this is going to enable us to build these types of applications with much richer experiences. You saw a whole range of those in the keynote yesterday in terms of the type of rich experiences you can build with Silverlight. The third piece to building Outlook Web Access, though, was how hard it was, right? It took a lot of time and energy to go about building this thing. All of the different differences in the browsers, the JavaScript perf issues. I've worked on a lot of different projects at Microsoft, and kind of regardless of your opinion about Microsoft, the term hack is not a kosher term with most developers at Microsoft. But the guys that were working on Outlook Web Access, it was a badge of honor. What was the latest hack they would find in the browser to work around some weird oddity? Their latest perf optimization they found with JavaScript. It was very difficult to build real rich applications in this model. And this is the point that the .NET Framework is going after. That's the whole point behind this, which is to make these types of rich experience applications easier to build. So what is .NET and Silverlight? It's basically taking the highly productive development framework we have, and if you've used .NET today, everything I'm going to show you today is going to look very, very familiar. It's multi-language support, C#, VB, all the other many languages that are available with .NET, including the new dynamic languages. All of the latest innovations, all of that 7+ years of work we've put into the .NET framework and are continuing to put in the .NET framework, we're rolling the right set of those into the Silverlight product. It also is tightly integrated with the Ajax libraries that we've shipped in the last few months. And of course, the great tool support with Visual Studio and the just recently released Expression tool, all of these same tools and frameworks for the full .NET framework apply to the Silverlight version of it. And of course, the key aspect here is that everything we're talking about today is cross-platform and cross-browser. I want to make sure everybody understands that, because you may be thinking, hey, I've seen some demos that are cross-browser, but I'm sure over here there's a bunch of Windows-specific stuff. That's not the case. Everything I'm showing you today, everything you've seen in the keynotes, everything we're building for the Silverlight product is cross-platform, works exactly the same feature support in all of our target platforms and browsers. Now, what are the pieces that make up our Silverlight application with .NET? Now, like we talked about in the keynote, we actually have 2 trains of the Silverlight release. We have the 1.0, which is available in beta form today. That's everything represented here in the kind of yellowish, in the kind of orangish colored boxes. And that is effectively the rich UI stack with a JavaScript programming model. That's in beta today. It's on track to ship in the summer. Now, everything in the kind of bluish box is the 1.1 release. That effectively is everything in the 1.0 release plus the .NET framework. And that we have available in alpha form today, and that's what we're going to be focusing on today. So effectively what that is adding in the core CLR. And like Scott talked about in the keynote, it's the full CLR. Effectively, the only changes we did is we took the full .NET CLR and we said, okay, there's some features in it that just don't make sense for web applications. There's a COM interop feature in it. Clearly, COM interop is not a very interesting scenario for this space, so we took that out of this particular SKU. There's a set of those things that just weren't applicable. And then we went through and said, we want it to be as small as possible, so we did size optimizations to it. But all those same size optimizations that we've made to the Silverlight CLR are being rolled into the full CLR, and we have one core CLR. Now, the framework libraries on top of that, what we're doing there is going through and doing refactoring and saying, okay, what pieces of the framework libraries do we need to have in the Silverlight release? And we'd go through and we said, we want to bring in some of the data. We need networking, obviously. We need XML. But when we do that, we'd say, what? We need a way to let you do XML parsing, XML writing, but do we really need to bring in the full, multi-megabyte XML stack that has support for XSD validation and full XPath support and all those pieces, or can we take a subset of it? So we've done that across the entire stack. We've actually been working on this project for quite some time, and what you'll find as you play with the alpha is as you go up the stack, you get kind of different levels of quality and doneness, right? The core CLR, the engine piece of that, we've been working on for quite some time. The types that are closest to that, things like collections and generics, ints, strings, things like that, those are also very solid. As you go up the framework stack, we have to kind of build from the ground up here. We've done the first level of pass of what we think we need, and we still have a bunch of things that are coming in. Nick will be here to talk about what we're doing in the UI space. And, for example, we have available in the alpha a control model, so you can go about building custom controls. But we don't have, we have a sample pack available, but we don't have built into the framework yet a full control library. That's the type of thing that we're still working to flesh out at the top layers of the stack. The other interesting thing in the Silverlight framework stack is in the bottom left, the deployment aspect. So deployment is really one of the key aspects of everything we're doing here. It needs to be small. It needs to be easy to install. And we have in there a friction-free installer. You saw it with the Chess app yesterday. It's a very quick, installs in seconds type model. We also have in it an automatic updater. The automatic updater is going to make it so that we can service it very seamlessly if we, God forbid, have any security issues, which we're doing everything in our power to make sure that we don't. But we also, that'll let us not have complete resets on platform adoption when we release a new version by allowing us to do easy updates. Just wanted to take 1 minute and talk about the relationship between Silverlight and the desktop version of the .NET framework. Now, really the key difference is size. The desktop version of the .NET framework, about 50 megabytes. The Silverlight version that we have available in alpha today is about 4 megabytes. I think it's actually like 4.2 currently. So like I said, we basically have gone through and cut out the pieces of the framework that we don't need. The Silverlight version, you can think of it as a subset of the full .NET framework. Now, it is the same core development framework, though. So for that subset of it, it is the same programming model. So if you're familiar with .NET and you move to Silverlight, everything's going to look very, very familiar. There'll be a few new APIs. There'll be some APIs that won't be there, as we did the factoring. Some of the APIs that we factored out, you can actually will be able to take advantage of in a more pay-for-play model. So as we go through different parts of the APIs, we'll say, hey, this piece of it should be in the core, because enough people are going to need that. But this piece is still kind of interesting. We don't want to put it in the core, but we'll let people take advantage of it in a more pay-for-play, bundle it with their application model if they need it. It's highly compatible. So what this means is that if you're writing code for Silverlight, because it's a subset of the full .NET framework, and you wanted to move that to the full framework, that'll be very easy to do. That may be an interesting scenario if you want to build an application that has a web front end and one that has a more traditional desktop front end. It's not a complete binary compatibility. There'll be a few code changes that you have to make, but it'll be a very easy transition process if you want to do that. The other piece I want to talk about is the sandbox. So if you're familiar with the full framework, in client applications, there's no sandbox. You can do whatever you need to on the desktop. You have full access to the client resources. With Silverlight, because it's a web technology, everything runs in the sandbox. I mean, everybody here is familiar with that. There's a sandbox, things you can and can't do in the browser. You can access, you can just do UI stuff. You can call back to the server that you came from for networking. You can't have unrestricted access to the file system. Same thing with Silverlight.NET applications. Everything runs in the sandbox. It's effectively the same what you can do, what you can't do model as the browser. There is absolutely no way to get outside of the sandbox. There's no elevation mechanism. There's no prompting. And what this means is that in order to run an application, it's just like a web application. You click a link, you navigate to a web page. Hey, that web page has Silverlight content that uses .NET on it. We take care of downloading the assemblies, and we just start running it seamlessly. There's no prompt, no user experience that gets in the way for the user. Now, what we are doing as part of this is we're trying to push the sandbox as far as we can safely. So what this means is new features like safe isolated storage. So isolated storage is basically a safe place on the disk that your application has access to store data. It's quoted, so you can only have so much space. It's obfuscated, so there's no way to really find the path for it. But it's a safe way for your application to store information. Client-based file upload controls. In the HTML DOM, you can do an input that lets you actually upload a file. But there's no way to actually access that file from the HTML, from the browser, from JavaScript. You have to upload it to the server and then do whatever you want to on the server. In this case, since the users picked the file, it's safe, we'll actually give you access to the file on the client side. So if it was a picture, for example, and you wanted to crop it, you can do that before you send it up. We're also working, when we talk about networking, on some cross-domain networking support, because that one's a key enabler in terms of building some interesting applications. So that we're working as part of our roadmap to provide a safe cross-domain access model. Okay, so enough overview. Let's talk about actually building things with Silverlight and .NET. So what are you going to need to get started? So everything that we're showing you today, everything you saw at the keynote, everything about Silverlight and .NET that you're seeing at the conference are all available on the bits that you can download and play with immediately. All this is available at Silverlight.net, links to what you need to download, samples, docs. What you'll actually need and what we're using on the machines up here to show you this are the following installs. Obviously, you need to install Silverlight itself. You need to install the 1.1 alpha. That's the runtime. That's the only thing you need to install on any machine that actually wants to run the application you want to build. Now, if you want to build applications, you'll also want to install the next version of Visual Studio, which is available in Beta 1. It's called Orcus. On top of that, you're going to want to install the Silverlight add-in to Orcus, which adds Silverlight functionality, like the file new Silverlight project support as part of this. And that'll get you your Visual Studio experience. If you also want to get the expression experience you saw demoed in the keynote, you'll want to install the Expression Blend 2 May preview, which lets you author XAML that's targeted at Silverlight. And the final thing that you may want to install is the ASP.NET Futures release, because while Silverlight will work great with any server, we've done some integration points with ASP.NET to do things like making it very easy to add Silverlight content to your ASP.NET server. So there's a preview of that functionality available as well. Okay, so we're going to build an app. Let's talk very briefly about what actually the app is. So any Silverlight application is going to have at least the following 4 things as part of it. It's going to have an HTML page, because this is just a web app. You're plugging Silverlight content into a root HTML page. You're going to have a couple JavaScript files. And the job of the JavaScript files is to take care of detecting if Silverlight's available on the machine or not. If it's not installed, then go about doing the user experience to actually get it installed for you. And if it is installed, get out of the way and just let the application run. So we've bundled that together in some JavaScript libraries to make it very easy for you. And the final thing is you actually need the Silverlight application. And any Silverlight application using .NET has at least 2 files. It has the root XAML file, which is your default UI, right? What UI shows in the HTML page. Then it also has an assembly. And the assembly is your DLL that has the IL, the instruction languages, to actually run with that XAML file, with that application. Now that's the minimum. Now Silverlight application is also very likely to include other application libraries. You can, just like you can build applications with multiple DLLs today, you can do that here as well. Your app could be composed of multiple DLLs. It could have a third-party DLL in it. It could have another DLL from Microsoft, potentially, that it uses. It could have other application resources, XAML files, images, other types of resources. All of these could be optionally embedded into an assembly. In fact, the Top Banana, the cool, slick video editing application you saw in the keynote, that was composed of a reasonable number of XAML files. All of those were actually bundled into a single DLL as part of their deployment. Now, one of the things that we are working on is zip packaging support. Basically, this is a container format so that if you want to deploy your application as one unit with all these files collected together, you can do that. So we're working on that. Right now in the alpha, though, the only thing that we have is loose file support. So you take these files, you deploy them to your web server, and then that's the mechanism that you go about running your application. Okay, so let's go ahead and get started. So the first 5 minutes here are going to look pretty similar to what you saw Scott do in terms of file new Silverlight project. So this is just Visual Studio Orcus with the Silverlight add-in pack installed. So you can come in here and you can say, oh, for my language Visual Basic, let's create a Silverlight project, let's create a Silverlight class library. The project is basically the app, the class library are supporting DLLs that your app would be using. In this case, let's go ahead and select C#, and we'll create a Silverlight project. And the app that Nick and I are going to be building today will be a fantasy baseball app in kind of the spirit of the MLB demo that we saw yesterday. So we'll just call this guy Fantasy Baseball. And this will create a new project for us. And one of the things it's going to do is create those files that I just talked about. So if we go look at what's available in our project, we can open up the HTML page. This is just a test HTML page to get us going. Inside of here, it has this call, create Silverlight. And what this call means is right here in the HTML page in this div tag, this is where we're going to be inserting the Silverlight control. Now, this HTML page has an associated JavaScript file in it that has this create Silverlight method. And this is what does the actual instantiation of the control. It has a number of parameters, like what's the width and the height and what version of Silverlight the application needs. The most interesting thing here, though, is that it has a page.xaml file. The page.xaml file is going to be the actual root XAML file that we run. The other interesting thing here is that there's another file up here, silverlight.js, that's referenced in it. And this, we're not going to walk through this, but it has all of the magic logic to do the redirects to Microsoft.com, the detection of whether Silverlight's installed, and that happens automatically for your page. If you go to the page, you don't have Silverlight, you got to get Silverlight. User goes through the install Silverlight process, then they can run the app. So if we follow our chain here, it takes us to our page.xaml file. Our page.xaml file has the setup for the root canvas, what the color is, what the size, the width, the height. But the really interesting property is the x:class tag. And the x:class tag has two things in it. First, it has a reference to the DLL. This is the actual assembly that is going to be loaded for this XAML file. The other thing that it has is the name of the entry point. And what in this case is the class page in namespace fantasy baseball. So basically, what happens, this XAML file gets loaded. We go to that assembly. The assembly gets downloaded. We look inside the assembly. We find the class that we're looking for. We instantiate it. When the XAML is done being loaded, this loaded event will be called. So if we go to the associated code behind for this is our C# file. You can see here we have class page in the fantasy baseball namespace, and here's the page loaded event that will be called when this thing actually runs. So this page loaded event, as well as with the constructor for this class, is your first opportunity to run managed code in your Silverlight application. So just to make sure we can all see this pretty well, let's go back to our XAML file and let's make this thing a little bit bigger, about 1,000 width and 800 heights. And let's change the color to be orange in the spirit of my alma mater. And then we hit F5, run, and away we go. And there we have a Silverlight application running with an orange background. Very impressive orange background, I know, you're blown away. So let's keep going. So like I said, the XAML file with our C# class is our first opportunity to write code. So if there's people in the audience saying, hey, I didn't want an orange background, if we actually want to go change that, we can do that. We can just go this, because we're in a canvas class, this.background, and we'll do new solid color brush, and we'll pick, how about green? Green sounds great. We run that, new managed code gets compiled, deployed, downloaded, and run. Now, one of the things I want to make sure everybody's crystal clear on, because if your only experience with .NET has been in the past, ASP.NET, you could be thinking to yourself, yeah, I'm used to this. Is the code running on the server? No. Let's be perfectly clear about this. The assembly is getting downloaded to the client. It's being run in the browser process on the client, right? So it's running in the IE process here. It could be running in the Firefox process. It could be running in the Safari process. So if we were to go close this and go set a breakpoints right here on this.background and hit F5, it starts up. We hit the breakpoint right away. I am now attached to the IE process where this code is running it. And now this is the standard debugger that Scott showed you yesterday. You can do things like hover over different properties, expand it out to see different values. You can go down, you can use the watch windows. We can use the immediate window. Let's say we wanted to change the opacity, which is how transparent the UI is. So let's say we wanted to make it very transparent at 0.2. Go run that line of code. Now we've just poked that value at the debugger. If we let it run, did I say 2? Excellent. I will need some technical support as we go through here, so it is very much appreciated. So let's, how about we do it right this time? This dot opacity equals 0.2. There we go, and we get a very semi-transparent green background. Simple enough. Now, we're going to be going through the different APIs through the rest of the talk. One of the useful things to kind of see what's available is to use the object browser. So if we open up the object browser, we can see what different functionality is available here. So the AGCLR DLL is the actual DLL that contains the UI pieces that Nick's going to be talking about in a minute. And you can come in here and you can say, okay, here's some namespaces. I can open up the control namespace. I'm sure most people can't actually see this. But I can come down here and say, oh, here's a text block, and the text blocks has a text property and a foreground property, and you can just navigate through all the different pieces. It's a very good way to get a feel for what's available. One of the other key differences about the Silverlight project from a normal project is if we were to go to the references tag, there's a bunch of assembly references here, and they're things like mscorelib, system.dll. These all should sound very familiar if you've used .NET in the past. But these are not the system DLL and the mscorelib DLLs that you're used to. These are the factored, subsetted Silverlight versions of these DLLs for this. So it's like mscorelib, but it has a subset of the mscorelib types in it that are targeted at Silverlight. And if you go do an add reference now, it'll add references to other assemblies in the Silverlight project that are applicable to Silverlight. So this is a very simple application. Now let's say that we actually wanted to add this to a website, because odds are you're building this content to plug it into a real website, not our test HTML page. So you can do that with any website, any technology. You just go put that HTML that I showed you earlier into that web page. We've also done some integration with ASP.NET. So we can go do add existing solution, or add existing project, add existing website. So we have a website already made, fantasy baseball demo here. And this has a number of web services in it that we'll be using a little bit later in the talk, and a few other things. It's also got a home page, which is just blank. What we're going to go do is, for this ASPX page, we're going to add our Silverlight content to it. So one of the cool things we can do is simply go to our Silverlight project and do right-click, Add Silverlight Link. And it detects what Silverlight projects are already in our solution. I can just say Add it. And now what it's going to do is actually copy over the assemblies that make up your Silverlight application, as well as the XAML file. And those will get updated every time we do a recompile. And now, if you want to deploy this website, everything the website needs is self-contained in the website, so you can just xcopy deploy the website and configure its vroot like you normally would. So in this case, I want to add our Silverlight content to the page. So I can just click and drag our page.xaml. So there I just added it to our page. And I can go resize and say, yeah, here's my Silverlight content that I want to add to the page. We can come down here to the property grid and change different properties for it. So I think we said we wanted 800 pixels by 1,000 pixels. You can just come in and poke at it. And now if we make our website our default project and our home page our startup page, now if I hit F5, I'm actually going to run the ASP.NET site. It'll start the ASPX page, run any server code that I needed to, and when it renders in the client, it'll load the Silverlight content as well. And hopefully it'll run in a second here. There we go. And here we actually hit the breakpoint that we had left set in our Silverlight application. We let that go. And now we're running an actual ASPX page with Silverlight content. Now, this is the basic framework for what it takes to get going with this. I didn't skip any steps at all. This is exactly what you have to go do. If you wanted to run the same application in, say, Firefox, we could go do that. Let's just pull up Firefox here, put in our same URL. Our Silverlight content runs in Firefox. If we want to switch over to our Mac and see it running in the Mac, we could pull up Safari. And I do apologize for folks for the clipping. It turns out when you're building a cross-platform solution that works on many different computers, you want to show it running on many different computers, and that doesn't make all the AV equipment totally happy in terms of what it wants to work with. So if we go here and we say demo 1 was our link, we're actually running the exact same Silverlight content from our server over here in browser in Safari. Now, obviously, the app doesn't really do anything whatsoever at all except display a green background. So now it's time to actually add some functionality. So I'm going to ask Nick Kramer to come up here and actually take over for me and add some UI to this. I'll be back in a little bit to talk about how we actually plug in web services data, those types of things. Take it away, Nick.
Thank you, JB. Where's my demo button? So before I get started, I just want to take a moment to say how excited I am to be here. We've been working on Silverlight for quite a while, and I'm really happy to be able to be here talking to a bunch of developers about what I've been working on for the last year and haven't been able to say anything about. And to be able to do this in Vegas, that's pretty sweet. So I hope you guys are as excited to be here as I am. We're going to talk a little bit about XAML to give you a little background about what kind of application, what we need to know to build this application. Just show of hands here, how many people feel comfortable programming in XAML? All right, so a fair number of people here. So for you, this is going to be a refresher. XAML, what is XAML? You've heard that already. It's our XML format for describing graphics and user interfaces. And one of the key things about XAML is that it's an extensible schema. You can add your own tags to it. It's also got a couple other nice attributes. It's enabling rich tooling, mostly by virtue of being XML, but it's also a very readable format. So I sometimes have people ask me, why do I care about XAML? I just want to use a WYSIWYG tool. If that's you, you can do that. We have some great WYSIWYG tools. You can use Expression Blend. We have tools in Visual Studio for editing XAML in a visual way, so you don't ever have to see angle brackets if you don't like them. But if you do like them, we have that power as well. It's a very readable format, and I'm going to use XAML a lot on slides because it's also a very compact format compared with the equivalent code. So I can fit more constructs on a single slide, which is really useful. Oh dear. I have totally goofed that. All right.
This is what I was talking about.
I hit the C button.
Oh. C, D, all the same.
Okay. Now, what am I supposed to press? All right, so it wouldn't be a conference if we didn't build Hello World on stage here. And this is just, the simplest XAML file you can write. It's got a canvas at the root. We're an XML file, so it has to have an XML namespace declaration declaring what schema we're using, declaring that this XML file is following the XAML schema. And it's got a text block in there that does the usual text block stuff. Got font size, has some text. One of the most powerful things about XAML is that the markup is the same as the object model. If you know how to write the markup, you know how to write the code. And this is one of those duh principles, but it's also really powerful if it's followed through really consistently. So if you know how to write a text box in markup, angle bracket text box, well, new text box is the code way of doing it. You want to set the font size in markup? Font size equals 32. Do that in code. Text block.font size equals 32. Who would have thought? So this canvas thing, what's a canvas exactly? Well, it's really just our container. It contains other XAML elements, like rectangles. And within that canvas, things are absolutely positioned. Here we say the rectangle has canvas.top is 25, canvas.left is 25. And that just means that that rectangle is positioned at the 25, 25 location relative to the upper left of the canvas. Canvases are useful because you can put them inside other canvases. So they make for a great grouping mechanism. And here we have a gray canvas. Inside it is a red canvas. And inside that red canvas is a white ellipse. And if we wanted to move, say, everything inside that red canvas, maybe we put 2 or 3 things inside of it, and we moved that red canvas around, that ellipse would move with the canvas. So it makes for a nice grouping mechanism if you want to move a number of elements at once. Talked about markup and code, how they're always a way of doing both ways. We said, rectangles inside canvases. How do you build that in code? Well, if you've used .NET before, you already know the answer. Canvas has a children property. Children is a collection. Collection has an add method. Canvas.children.add rectangle. And children, of course, is a collection and has all the other collection stuff as well. You can look at what other elements are in this children collection. You can insert things at specific locations. You can remove elements. You could probably even sort them. Haven't tried that one, honestly. Don't see a use for it, but you could do it if you want, I think. The other funny thing I showed you about the markup a second ago, canvas.top. What's that about? It's kind of a funny looking property, isn't it? And this is an example of an attached property. An attached property is simply a property that was actually defined by the canvas, but that's set on the rectangle. Rectangle doesn't really know what it means. Canvas provided the definition of it. This is something we use for properties that are kind of contextual. They only make sense in certain contexts. It only makes sense on a rectangle if the rectangle is inside a canvas. And today, everything's inside a canvas. Tomorrow, that's not going to be the case as we add new layouts to the system. And so the programmatic way of setting an attached property is to call setValue, rectangle.setValue, and then you tell it what property you want to set, canvas.topProperty, and you tell it the value you want to set, which is 25. So with that little background, let's start writing some XAML. Now, I wanted to do a fantasy baseball application. Fantasy baseball, for those of you who are not familiar with it, it's about you take real players and you draft them onto your fantasy team. So when a real player hits a home run in real life, your fantasy team scores a home run. And you do that across a whole bunch of statistics, and then at the end of the day or end of the week or whatever your league plays, you compare who has the best aggregate statistics. And so the way to win at fantasy baseball is to analyze huge numbers of statistics, looking for the best players with the best stats. And it's really a giant data visualization problem. And so I thought that would be perfect to build in Silverlight. Now, we're going to get started here with a little bit of XAML. I took the liberty while Jamie was wrapping up to very, very quickly improve the project a little bit. Just show you what I did here. I started off with, instead of showing a blank page, which is not very interesting, I edited a little bit of XAML here. I'll show you in a second more how I did that. I also added a new control here, which we're going to build later on in the demo, but I didn't want to force you to watch me do this sort of thing in the dialogue all day, where I just add new item and then typed in some names. I also added a couple pre-built controls in here. There's a little subdirectory, a couple different files here. We ship a sample pack of controls with Silverlight 1.1 alpha. I just went in, I copied my 5 favorite controls, put them in here, and then I changed how they looked. I had the source code. I could do that. So I did. And one other thing, this is a baseball statistics app, really, and it's all about players. And so we need to define a player class. So that's what I did. It's just got the obvious stuff. You know, your players have your names, they have positions, they have a bunch of statistics. And I also needed some kind of data to work with. We're going to be visualizing data, and later on, Jamie's going to show us how to get real data off a web service, but he's not available quite yet. So we needed to work with some fake data, so we had something to visualize. So I have this wonderful method here, create fake players, which does exactly what it says it does. Now, I said I'd talk to you a little bit about what this XAML did. Let me show you how I built this. I went into Expression Blend, and this is what it is now. I just went in there, and I dragged and dropped a bunch of stuff until I was happy with the way it looked. And we'll just kind of show you a little bit more about what this is. This is still mostly empty because we're about to add good stuff to it, but just to have fun with Expression Blend here, you can zoom that up a little bit and see what we're about to do. And while I got it here, let me also show you a couple things about how I structured this program. There's our parent canvas, which is everything. We have this little thing called the main canvas, which is this giant white region here. We're going to use that later in the demo. There's also this spinner thing. Spinner is currently invisible. We'll change that over here just to show you what it looks like. And this thing in the middle is a doohickey we're going to spin around while we're waiting for network traffic. That will be our signal to the user that, hey, don't worry, the app's not hung, we're downloading stuff. And so just to prove this file's real, I'll go ahead and save it out. We'll watch how Visual Studio picks up that the file was changed. Do you want to reload it? Yeah, sure, why not? Click yes, or hit F5 to run it, and we'll see. Now, we're going to have that application with that little spinner control in it. It's a little small, isn't it? And so that is our cue to go back and learn a few things that could help us make that application a little bigger. Before I do that, let me just set the spinner back to where it used to be. Hidden, collapsed, same thing. And we'll go back to our other machine here. Yeah, I got it right this time. So in Silverlight, every element supports this notion of transform. You can apply this, transforms can be applied to canvases, to rectangles, and to everything else in between. And there's a variety of different types of transforms. There's rotate transforms, there's scale transforms for the x or the y dimension, or both, and we're going to be taking advantage of these. There's skew transforms, there's translate transforms, and there's even combinations of all the above transforms. To do this, a transform is potentially a complicated object in its own right. Angle bracket, render transform, angle equals 45. There's 3 or 4 more properties you can set on that transform, such as the center of rotation. And so you want to express this thing in XML. But wait, earlier I said that properties are attributes in XML. Well, actually, they can be attributes, but they can also be elements. And here we see a syntax known as property element syntax. And that's, by doing that angle bracket SumClass.SumProperty, you're saying, hey, I want to set this property using property element syntax. It's potentially a rich, structured object. I want to use that rich XML structure to express that object. And so all this is really saying is there's a text block. Text block has a property called render transform. I want to set it to this object called angle bracket rotate transform. And that code down there just does the equivalent. So let's put that into practice here. File has been modified. Sure, let's reload. So all we have to do here, go into our canvas. Canvas will have a render transform. Looks like I put it in just not quite the right place. So canvas has a render transform property. Inside that render transform, we'll put a scale transform. It's as easy as that. And now we'll have rescaled the entire application. And so now hopefully the people in the back row can see what I was talking about earlier with this app. So I also want to start visualizing something. I mean, I said this is about visualizing data. So far, I haven't showed you any data. Well, let's get to work on that. So we're going to go into the code behind for this file, which is there's page.xaml and there's page.xaml.cs. And what I've done offline here is I've created a chart control. You can write rich controls in Silverlight, and we're going to show you chart's a little bit involved. I'll show you a little more straightforward control a little later on. I say involved, but at some level, a chart's actually a pretty simple thing. It's a whole bunch of rectangles, text blocks, and canvases. It's only using 3 different kinds of elements. But it does that over enough lines of code that's a little more than you really want to see me talk about right now. But a little longer a speech there. But we will build another custom control later on, just to show how simple a custom control can actually be. But for the moment, let's use one of those chart controls. Let's just do it right here. We could do this in XAML or code. Either one works fine. Let's do one in code, then we'll do the other in XAML. So just declare a nice little private field, private chart. And we're just going to new the thing up. Chart equals new chart. Chart.width, set the usual properties, set its width, set its height, set some top and left properties, stuff you've seen before. And of course, doesn't do anything if we don't add the chart to the main canvas so that it's actually displayed. All well and good, but we still haven't given the chart any data. And so one more line here. Our famous player.create fake players. And let's see what that does. And so what you're going to see is you're starting to see the power of visualization. A chart full of numbers, it just doesn't really do it anymore. You can't really see who's the good players and who's the bad players. It doesn't jump off the chart at you. We're here with a little bar graph. We're also color coding the information here. Red means a bad statistic, yellow is a okay statistic, and green is a really good statistic. We can see right now who are the players we really want to draft before Jamie gets back here. That guy looks kind of good. He's a little low in stolen bases, but otherwise not bad. But what I'm finding, I can select them. I can't actually draft them. What we need to do is build out a draft button so we can actually draft some of those players, send that request off to the server, and actually get those players on my roster before Jamie can steal them from me. So I want to tell a little bit more about how we're going to do that. We're going to be using some custom controls, and we're going to be doing some event hookup in order to add that button with its nice click handler to the form. So there's a bunch of events in the system. I'm not trying to list all of them here, just kind of a sampling of some of the more common events you'll see. There's kind of the usual mouse stuff. You got your moves, your enters, your leaves, button up, button down. We also have our keyboard stuff, keyboard up, key down, got focus, lost focus in Silverlight. Loaded event is another event you'll encounter a lot. We've seen that one already. That's how you know your page is done loading, and your opportunity to write some code to manipulate the page before you show it. There's other events in the system as well. They're more element specific, but these ones apply to everything. How do you hook up an event handler? Well, again, if you've done code in .NET, you already know the answer. Programmatically, just use your language's event hookup construct. In C#, something dot mouse event or mouse enter plus equals name of method you want to do the handling. If you want to do the event hookup in XAML, it's just name of the event equal sign name of the method you want to call. And on mouse enter could have been called anything you felt like. If you're using a different language like VB, again, use the syntax that you're used to using in that language. In VB, the syntax for hooking up an event handler is that you put a handles clause after the method signature, handles canvas.mouseEnter. And like any other library in the Visual Basic library or .NET library, that's how you hook up your events in VB. The signature for this event is, again, just like every other .NET event. It's got a void return type. It's called whatever you want. It has two parameters. There's a sender parameter that tells you who sent the event, the canvas in this case. And there's an event args that tells you information about the event, like where exactly is the mouse if it's moving and entering. When you're doing the event handlers, a really useful thing is to be able to refer to the elements you have in XAML so you can manipulate them, set a background or a height or whatever else. All you have to do is set an x:name on that element. And so x:name equals rectangle or equals rect just allows us to encode rect.height equals 75. Because we put that x:name, Visual Studio knows he's talking about that element in XAML. That's what I should change. Another thing that talked a little earlier about how powerful XAML is to extend, how powerful a concept that can be. So we said a couple times, there's not built-in controls in the XAML schema right now in Silverlight. Angle bracket button doesn't have a built-in meaning. So instead, we've provided rich ways of defining custom elements. And all you have to do to use them is declare some XML namespace information. So you need to declare a namespace prefix. You can call it whatever you want. You can call it literally prefix. You can call it custom, whatever. Some kind of short little name that you'll use in the rest of your XAML file. And that XMLNS declaration goes at the top of your file. And in that, you need to tell Silverlight where to find this custom control. So in this here, it lives in the CLR namespace, sum namespace, and in an assembly called sumassembly.dll. And then when you use that custom control, you have to give your prefix. It's just standard XML, angle bracket, prefix, colon, whatever the name of the element is you want to use. That's just standard XML namespace stuff. Let's show an example of this. So we wanted to do the draft player button. So let's go back to our XAML for this page. Let's go down to the bottom of the page. Seems like a good place to put some stuff. And we'll do it this way. Let's not do it that way, I guess. I don't know what it is going to drag that. Let's not drag it there, though. So we're going to put in a little button twice. And here you see controls:button, we're doing that XML namespace prefix. It's not in the default XAML namespace, so we need to tell it what namespace it is in. And that button is going to have the usual element stuff. It's got an x:name, it's got a width, a height, canvas left, canvas top. It's also got these two things at the bottom, a text property and a click event. So not only are we adding new tags to XAML, we're also adding new attributes, new properties and events to XAML. These are things that were defined by the button class. And so we're using controls:button, but we haven't given an XML namespace declaration for that. So let's go up here and do that. Put that in that line there. Let's wrap this around so you can read it a little better. And so the namespace, that button class, is going to be located in Fantasy Baseball namespace, fantasybaseball.button. And it's going to be in a file called client bin/fantasybaseball.dll. That's where the XAML parser can find the code for this thing. Why is the button inside the render transform? I do not know, and thank you for pointing that out. Let's make sure we don't have any other buttons in interesting places. All right, that looks good. Let's go to the code behind again. Now we have a button on a page. I put a click event handler there pointing to a method that doesn't exist yet. So let's make sure that method exists. We shall. It's got, again, the usual signature. You can make it private method if you want. You can make it public if you so feel. Private's a little more typical. And inside that, we'll do something like set the chart's data. So when we click, as we select players, this is interesting. What have I done? Just pasted a snippet in the wrong place. Nothing to worry about. So it just kind of shows the validation as well. We're parsing that at compile time. So if you have invalid XAML, we will show that off. All right, somewhere along the way, I blew out the scale transform we had. So let's just make sure we get that back so we can all see in the back row there. Oops. See where I should have put it. All right. So you can see now we have a button over here in the upper right corner. And as we select players and we click on it, we're going to run that line of code we just wrote, which is take the selected players, remove everything else from the chart, and just select what you've drafted. There we have just a simple event handler there now. All right, so I also want to show you a couple examples of writing custom controls. It doesn't have to be a hard thing. You know, custom controls sounds like a scary thing, but it's not. We write custom controls every day without even thinking of them as custom controls. You see that previous page, next page, forward a page, last page, what page am I on thing. I see that on so many web pages. That's a control. Let's write that as a control, as a reusable chunk, so that we don't have to write that thing over and over again. And we don't have to do much to do that. We just have to derive from a class called control, and we have to define the look of the control in XAML. Or I should say, we don't have to. We can define the look of the control in XAML. If you want to write it all programmatically, that's also an option. You have to call initialize from XAML and pass it the XAML you want the control to display, and it helps to remember the return value of initialize from XAML. If you want your custom control to be usable from XAML, there's a couple extra steps you need to go through. You need to make sure the class is public, that it has a public constructor, that the public constructor has no arguments. So that's just how the parser is going to instantiate it. It goes angle bracket button, new button. So that's all that's about. And if you want to add additional attributes for properties and events, just make sure your properties and events are public. Let's put that into practice here. So we'll close out our application here. And again, I'll show you what we got here. We have previous next page.xaml. Again, I took the liberty of defining this offline so you didn't have to watch me drag shapes around Sparkle for half an hour, around Expression Blend, I'm sorry. So we'll go into the project here. What Expression can do is open your entire solution, so every file in your project is nice and handy. We'll go ahead and do this. So this is a little hard to see. What I'm going to do is I'm going to set a temporary background of this. Just go in. Okay, brushes, background has no brush. Let's change that. Click there. Black, not the color we want. Nice color chooser. All right, so you can see what we got there. We can even make this a little bit bigger. Hint of the day in Expression, hit the Tab key, all those tool palettes go away. I love that feature. So you can just see what this is. It's just a text block that says page 1 of 8, and it has a couple little shapes on the side. Now, just kind of, some of those things are nested in canvases. I got, canvases within canvases, so I can move all the things on the left, I can move around at once. And we have a nice little text block. Text block has a name, so we can programmatically update it to the correct page. So now that we've defined our XAML, we need to use that initialize from XAML thing I talked about earlier. Have our XAML, need to actually tell the system about it. So this line of code here, Visual Studio generated for us. And this does the job, but it's kind of hard to read on this monitor, so I'm going to blow this away and replace it with something a little more readable, I hope. And so here we have the same thing on 4 lines of code instead of 2. And this last step here, initialize from XAML, pass in the XAML we have. Now, the platform, Silverlight, doesn't really care where you got that XAML from. You can get that XAML off a normal HTTP request. You can download it from a web service. You can generate it programmatically. You can store it as a giant string literal inside your C# file if you feel like it. But the most convenient thing for me personally, and what we use in Visual Studio, is to embed that XAML file inside a DLL, and that way, whenever your DLL has been downloaded, there's no additional download you need to wait for. And so that's all the other 3 lines of code are doing. First, we find the DLL, assembly, then we find the resource stream out of the assembly, and then we just turn that stream into a string, and we're back where we started, where we initialize from XAML with the XAML we just loaded. And so while I'm here, I'm also going to hook up that text block, provide a name for that text block we saw earlier. We will just drag the field out here. So we're going to have a private field called text block. And this is, in the page case, Visual Studio generates this for you. This is how Visual Studio provides the X:" names for you in the page case. It just says X:"page, I need to put in a private field called that thing he used the X:" name on. And Visual Studio will also say, okay, how do I initialize that thing? I just call find name and cast the result to the appropriate return type there, a text block. And so let's do one more thing. We've defined a perfectly valid control at this point, but we haven't actually used it anywhere. It's not going to look like a whole lot if we don't actually put it into our application. So let's do that. Let's go down to the bottom here. And we will just use it right here. I could have done this in code, but why not? XAML code, flip a coin. And again, we just kind of do all the obvious stuff. It's angle bracket controls : previous next page, because it is that extension to XAML we're doing there. It's got the usual left and top stuff, and it's got an X: name so that in the application we can refer to it as well. And so let's give that a whirl and see what it looks like. And so now you can see down here at the bottom, we have this previous page, next page experience going on. Unfortunately, it's not interactive. It doesn't do anything yet because we haven't hooked up any event handlers. So let's do that now. So there's 4 buttons in here. I'm not going to hook up all 4 because it gets a little tedious, but I will hook up the next page button. So all we have is we have a canvas. It's nicely labeled next page so I can find where I am. And this canvas contains a couple different shapes, as well as if you did this in expression blend. I used render transforms. I actually had the left side and the right side buttons were the same, except I flipped them around. So that's all that's about. And inside the next page button, let's just find ourselves a nice little event handler. Mouse left button down equals on next page. And we'll go back to our code behind for the control. And of course, we need to define that method. But before we get there, what page are we on? We ought to define a page property so that someone who's using this control can know what page we're talking about. So let's do that. Let's just define the really obvious property. It's got your private field backing it. Backed by a field, it's property with a get and a set. And the set does exactly what you think. This is also a great opportunity to update that text block. Have it show the actual page and not just whatever page I hard-coded it to. So do that right here. And this is just as obvious as you think it is. Textblock.text equals new text. And of course, we still need to define that method for the on mouse down. So go in here and we'll do that here. I have the right number of braces. I'm off by a brace. And so it's, again, your standard event signature stuff. And it will simply call into that page property and increment it. That's what a next page does. It increments the page count. And so when we do this, we're going to see that we now start to have some interactivity. When I click the button here, it goes 1, 2, 3, 4, 5. But the chart's not updating because while the application could ask what page it is, we're not providing any events for the application to hear that the page has changed. So let's do that. We'll define ourselves an event just like we would any other .NET event. Here's a good place. It's just public event is the C# syntax for doing this. Tell it what kind of event you want. We're just going to have a generic one, a generic event args event that has no parameters to speak of. And we're going to call it page changed. Okay? Now, of course, we need an event's all nice and good. You need to remember to fire the event occasionally. Otherwise, your event really didn't accomplish much. So let's do that. Down here inside, when the page property changes, let's do this after the text block, I guess. All we need to do is, again, standard C# pattern. If someone's listening, then fire the event. And of course, the application isn't currently listening to this, so that's what we got to do. We need to tell the system to start listening. I'm not quite sure what I did there, so let's undo that. And right here in XAML, page changed equals on page changed. And you already know what the next step is. We have to define the method we just said to hook the event up to. So down here, let's just do this step. And that will hook up the pagination for us. Now you can see, as you click around, the chart's updated because we're handling the event and we're doing something useful in response. And so while I'm here, I realize that I don't think I've showed you the networking part of this. I forgot, I had that wonderful spinner in there, and Jamie's going to be up in just a few minutes to show us how to really hook up networking. We better start working on that progress animation. So again, just remember earlier we had that spinner defined in the XAML somewhere. It's something I just drew in expression blend, so I honestly didn't pay a lot of attention to how beautiful the XAML looked. And all we have to do to animate that thing is we're going to do two things. We're going to define an animation in XAML, and then we're going to trigger it in code. Now, where did I put the animation for this? Here we go. So canvases have a property called .resources. And this is another example of one of those property elements, where we're going to stick potentially complicated objects inside the .resources property. So we want to use our property element syntax. And what we're going to put inside the resources collection is going to be a storyboard. A storyboard, you can think of a storyboard as a collection of animations that all get started at the same time. In our case, there's really only one animation we need, which is this. There's only a single thing we need to animate. And all this does, walk you through it here. We have an example of an attached property, storyboard.targetName. This simply says the name of the element we're going to animate is called spinner rotation. The property we're going to animate is angle. We're going to animate it from 0 to 360 degrees. And we're going to do this over a course of half a second. And then we repeat this 5 times. So fairly straightforward stuff. This is an animation, but we need to tell the system when to start the animation. And the right time to start the animation is inside the click handler for that button, because that's going to be our signal when Jamie gets back to really add networking. But for now, let's just fake something here. Let's just fake an animation, fake a network delay, so that we at least get to test our animations out. So to do that, I'm going to do a little more than I wanted. So I'll do a couple things. Actually, we're going to make the chart invisible while we do that. So there's a greater transition, a nicer looking transition from the all players to just the successfully drafted players. We also, of course, need to make that spinner visible. We can animate it all we want, but if it's invisible, I mean, that doesn't really do us much good. Of course, we need to begin the animation. That was our whole reason for going this route. And when that animation is over, we want to hear about it so that we can set the visibility back to where it used to be. So we'll hook up a completed event to the animation. And we can just do this and just kind of show off Visual Studio for a sec. This is one of my favorite features of Visual Studio, is that...
No variable for animation.
What's that?
No variable for animation.
Good point. So what I forgot to do here, I forgot to hit F6, and what that does is it refreshes the code behind. That x:name, it's in my XAML already, but because I forgot to hit F6, this is just kind of a limitation in the current alphabets. Visual Studio hasn't caught up with the fact that I introduced x:name earlier. And now, Visual Studio will not only tell me the possible events this thing has, .completed. We've had that for a long time. These are not new features, but I still love them so much. Plus equals, it'll actually start writing the method signature for me. Just hit tab a couple times, and it's already written the method signature for me. So old news to most of you, but I love that still. And so down here, let's just do what we said we're going to do. Now that the animation is over, let's set it back to where it came from. Visibility of the spinner is invisible, and the chart's visible once again. Now let's check that out. So select a couple things, and hit draft. And now we added a good user experience for that network delay in what, 3 minutes? So I've told you a lot about what are we doing today in Silverlight? What's available today in the 1.1 alpha of Silverlight? I wanted to talk a little more about some of the other systems we have available, or some of the other features we have coming down the line, as well as a little bit of a comparison between 1.0 and 1.1. So just limiting myself for the moment to the graphics and UI space, what's the difference between 1.0 and 1.1? Well, 1.1 has everything in 1.0, plus it has managed code. That's the big thing. You also get, as kind of a bonus pack, you also get some XAML extensibility. That ability to add new classes to XAML is something that's available only in managed code. You also get that control base class, which is simple but powerful. And you get a nice sample pack of controls. You get a nice pack that has your buttons, your list boxes, your scroll bars, all built in already. So I wanted to also give you a sense of where we're going, what we're thinking about. I mean, I don't want to call this the plan. I want to tell this, here's what we're thinking. Please let us know if this makes sense. Please let us know if you think this is the right plan or the wrong plan. We're thinking about adding all the obvious controls, or all the obvious simple controls, I will. Your buttons, your text boxes, your scroll bars, your sliders, kind of all the really obvious common controls. As far as the more complicated controls go, our thought process here is we shouldn't write these instead, or in this time frame, let's instead focus on making sure you guys can write these, that you have the facilities you need to be able to write any control that we could have written. No secret APIs for us. Put it all out on the table. In the layout space, we want to add some richer layouts here. We want to add a grid or a table or whatever you want to call it, something with rows and columns. And we also want to add some stack panels, which is simply put one thing after the other until you run out of space. Make each thing as big as it needs to be. So kind of the obvious layouts there. Maybe we'll do a view box as well. And we'd love your feedback on what kind of layouts, what additional layout functionality you'd like in the platform. A couple other areas of the platform that are interesting. We have mouse and keyboard events today. I don't think they're all singing, all dancing. They're pretty good, but they're not everything. And just kind of FYI, we know that. We're working to build these out a little more. They're pretty good at an application level. They have a few, they're not as good as they could be at kind of a componentized component control level. And that's where we're putting most of the effort in. There's the dot resources property you saw earlier is currently restricted to animations, but we'll build that out into a more generalized dot resources functionality for reusing snippets of XAML in your same file. Data binding is another example of where we want to go. And this is a great example of feedback. What does yes really mean? To be honest, I don't know what that really means here. I'd love your feedback on what are the core scenarios you're trying to hit. And also kind of brings up a good point that the yes in the WPF column is like a great big yes. There's a lot of functionality in WPF, and that lot of functionality takes a lot of time to download if we just take it all. So we really want your feedback on what are the core scenarios for all of these things that you need to do so that we can make sure we get the core scenarios that you need without bloating the platform with functionality that you don't need. And so styling is in the same bucket. Styling, to me, is actually a couple different things. It's doing a collection of properties that you can apply here, apply there, apply over and over again. It's also the ability to restyle a button or some other built-in control. And say, on the web, a button that looks like a Win32 button, it doesn't really fit. So a button has to be able to look like the way you want it to look, which is what I just call styling. And so there's a couple other features that are available in the full desktop that don't really make sense on the web. 3D and hardware acceleration really go together. Those are things that you really need to take advantage of the hardware to be able to show true three-dimensional images. You can do kind of pre-computed 3D and various pseudo 3D. But the full general 3D thing is something that requires hardware acceleration to really get a great experience for. Out of browser, hard to have an out of browser offline web experience. They don't really go together. And cross-platform, of course, that's why we're doing this. Let me just show you real quick what I mean by cross-plat. So the thing that I love here is I was a bad boy, and I didn't test this one bit on Firefox. I just assumed this was going to work. And, the developers on my team really bailed me out because it did just work. I just typed in the URL, Firefox, IE, Firefox, IE, Firefox, IE. They look exactly the same. So that's exactly what I want to see out of the platform. I don't want to spend my life trying to debug, why does it work slightly differently on the Mac than on Firefox? I hate doing that stuff, and that is what makes this a great platform for me. So we're going to take an intermission here. We have a long talk and a lot of material. Jamie's going to come back and talk about networking, XML, link, and kind of all the things you need to do to turn this UI into a fully functional application. And so what time do we have here? Back in half an hour, I believe. At the time, we'll start at the scheduled time on your little handout. And Jamie and I will be up here to answer any questions if you want to ask now, or we'll have microphone questions at the end of Jamie's session. Thanks.